Welcome to This Explainer. Today, we're diving into what's probably one of the most widely misunderstood acronyms in the entire tech and project management world. I mean, if you've ever sat in a technology planning meeting, you've almost certainly heard the term SDLC thrown around. But depending on who's actually speaking, well, they might be talking about entirely different things.
So, let's start with a provocative question, just to see if you might be suffering from that widespread silent confusion that plagues modern tech meetings when this four-letter acronym gets dropped. You might be a software developer who confidently answers, "Oh, that's the software development lifecycle." But then the network engineer sitting right next to you might shake their head and say, "No way, it's the system development lifecycle." So who's actually right here?
Well, the reality is they both are. SDLC actually stands for two completely different yet deeply intertwined concepts, and honestly, it is absolutely crucial to understand the difference if you want to avoid some major project failures. Let's untangle this and uncover exactly what the system development lifecycle and the software development lifecycle really are and how they relate to one another.
Here's our agenda for today. We'll start with 1. The Great SDLC Confusion. 2. System SDLC, the macro ecosystem. 3. Software SDLC, micro applications. 4. The nesting doll effect. 5. Navigating the speed mismatch. And finally, 6. The ultimate project risk.
Starting off with Section 1, the Great SDLC Confusion.
Because both of these frameworks use the exact same acronym, executives and engineers, they often just talk right past each other. And this isn't just some silly semantic issue. It literally leads to dangerously misaligned timelines. Imagine a situation where the software is completely coded, it's ready to go, but the physical hardware required to actually run it is still months away from delivery. People often falsely assume that if the software works, the overall system is a success. But that completely masks the massive dependency between physical infrastructure, human processes, and the code itself.
Okay, moving to Section 2, System SDLC, the macro ecosystem.
Let's pull all the way back. The system development lifecycle is a really broad, high-level framework. You have to remember, a system isn't just a piece of code. It's a whole ecosystem. We're talking about procuring physical hardware, servers, routers, the whole shebang, establishing business workflows, managing the data, and crucially, training the actual human users and administrators who will interact with it. Ultimately, it's designed to solve broad organizational problems. These specific phases, which come from standard NIST and ISO practices, guide the life cycle of that entire ecosystem. It all starts with analyzing business costs and feasibility in the initiation phase, moves right into designing physical network layouts, and then involves heavy acquisition, like actually going out and buying the servers and equipment. Then it moves into operations. And it's super fascinating to note that according to the Institute of Internal Auditors, up to 80% of the costs and time spent on a system over its entire life cycle actually occur in the operations and maintenance phase well after it's been implemented. And finally, it ends with a formal disposal or retirement of the hardware and data.
Now for Section 3, Software SDLC, micro applications.
Zooming in now, the software development lifecycle is a much more focused process. This discipline is dedicated strictly to dealing with actual source code, user interfaces, data models, and specific software functionalities. It really doesn't care about where the physical server is housed, right? Its core goal is simply to build an operational, bug-free software program that users can actively interact with. If you look at the steps, you'll notice a real structural similarity to the system lifecycle. We still have planning, design, and maintenance, sure, but here the steps are narrowly focused. The design phase is all about UI and UX wireframes. The implementation phase, that's entirely about writing code in languages like Python or Java. Testing is strictly about finding software bugs, and deployment is just about releasing that software to an app store or a cloud server. And this brilliantly illustrates the contrast between the two. The system SDLC is broad and holistic. It brings in network engineers, project managers, and executives to solve big infrastructure problems. Meanwhile, the software SDLC is narrow and super specific. It involves software developers and UI designers focused purely on applications and APIs.
That brings us to Section 4, the nesting doll effect.
So the absolutely crucial point here is that the system SDLC is the overarching macro framework, and the software SDLC is actually a nested micro component right inside it. Think of it kind of like a parent-child relationship or an umbrella that covers multiple disciplines.
See, when system architects reach the implementation phase of their massive project and realize, hey, we need a custom application, they trigger an entire software SDLC process entirely inside that single phase of the broader system lifecycle. It's like a giant puzzle.
To really ground this concept, let's use an analogy. Think of the system SDLC as building a smart airport. It deals with buying land, pouring concrete for physical runways, installing hardware scanners, and hiring TSA staff. The software SDLC, on the other hand, is just writing the code for the specific baggage tracking app used in that airport. Now, the app is critical, for sure, but it completely relies on the airport's physical scanners and servers to actually function.
Let's look at Section 5, Navigating the Speed Mismatch.
As you can see, there's an inherent friction between these two processes. Software teams today heavily favor agile or DevOps methodologies, right? They work in these rapid, 2-week iterative sprints. Because it's highly flexible, you can easily change a line of code. But system teams, they often must rely on a traditional, slow, highly planned, linear waterfall approach. Why? Well, because system development involves massive, inflexible sunk CapEx costs. You simply cannot undo a $500,000 physical server purchase just because you changed your mind mid-sprint.
This mismatch creates some massive vulnerabilities. Your agile software teams might finish their work incredibly fast, only to end up sitting idle, waiting months for hardware procurement and supply chains to catch up. Furthermore, you can write perfect, flawless code, but if the legacy network bandwidth is too weak to support it, or if you ignore the human element and users resist adopting the new workflow, well, your flawless software results in a total system failure.
And finally, Section 6, the ultimate project risk.
The single biggest overarching risk occurs right where these two life cycles collide. We call this the language barrier and the dependency trap. If your software engineers are sprinting ahead in Agile and your infrastructure executives are slowly plotting out physical upgrades in Waterfall, and they simply assume the other is on the exact same schedule just because they both said they're following the SDLC, man, you are walking into a costly disaster. You can literally never ignore the macro system for the micro software.
So I'll leave you with this final, provocative thought to take back to your own organization. We know the baggage app is entirely useless without the physical airport. So the next time someone brings up the SDLC in a meeting, pause and ask, which one are we actually talking about? Ensure your teams are speaking the same language. Thank you so much for joining me for this explainer.